Alright, let's figure out how to figure out the volume enclosed by a rectangular prism. So a rectangular prism is made up of um, two bases that are rectangles. So you start with a rectangle, and just this is kind of a face-on view. So imagine I'm seeing this from a certain perspective, so I know that this is a parallelogram actually on the screen, but it's as if you're looking down at it. So this is a rectangle. So imagine, if that side is has a length of 3 units, that's 3 units, that's 5 units, it's 5 units. Okay, so you start with a base like that, and then you connect it to a base the same size via some faces like this. Okay, that's a really bad drawing of this sort of okay drawing. So that's what we're doing here. Um, we've got two bases that are rectangles and they're connected by rectangular faces. So how would we find the volume of that, or the volume enclosed by that? Well, volume is kind of like area. When you're only dealing with two dimensions, let's say we got this two-dimensional figure here, this squarish type thing. Um, the area of that object is the amount of space enclosed by its side. So it's whatever amount of space this is. And for a square, well, this is actually a rectangle, so let's do that. So we would call this its length. Um, we call this its width. So the amount of space enclosed by this rectangle is just length times width. Alright, so now we want to take it into the third dimension and think about how much space does a three-dimensional figure, a solid, how much space does it enclose? And so how would we figure that out? Well, what do we have here? We've got two bases, and let me just pull off one of the bases here. And we've got the length of the base, and we've got the width of the base. Alright, and to create the prism, we take that base, I'm going to copy it here. It's kind of like, I'll do it this way actually. You start with a base that's a rectangle, and it's sort of like you're just stacking on a bunch of rectangles that are the same size, making it three-dimensional. You can think of it as you're translating this base along a line. You're kind of shifting it along the line and carving out a prism. So this is not exactly perfectly right, but so now I start with a two-dimensional figure, and I've kind of translated it through space, and now I've got a three-dimensional figure. It's not exactly perfect. So yeah, what happened here? So this distance from where you started to where you ended up is called the height. So the height, this dimension is called the height of the prism. The distance from one base to the final base. All right, so with these three dimensions, we can figure out the volume. So to find out the area of just a base, we do length times width. And then we're taking that base and we're creating all these kind of little slices that are stacking up on top of each other to get to the final base. So what do? We just multiply it, this area, by this total distance, this height. So then that'll give us kind of all the areas of all these little rectangles all together. So yeah, so the volume of the enclosed by the rectangular prism would be the length of the base times the width of the base. Let me draw a proper W. It's okay. The length of the base times the width times the height of the prism. And that gives you the amount of space enclosed by that prism.